Good evening, everyone. Good afternoon and good morning, wherever region you are situated with. We welcome you on board on the webinar series hosted by Green Story. Uh, for this, we have a webinar today titled Embedding Carbon Renewable Technologies into Fashion Supply Chain with Puro.Earth and Green Story. For this webinar, we have our esteemed speaker, Mr. Alvin Lee, who is a regional head, APAC region, Puro.Earth. We welcome you, Mr. Lee.
Thank you
Here's a
very
brief
much.
introduction. Yeah, here's a brief introduction about Mr. Elvin. So he has done his master's and bachelor's from Stanford University. So he started his career with JP Morgan's Risk Management Advisory team. Later on, he also worked at MSCI and IHS Market, which is a part of S&P Global. Currently, he is at Puro Earth, which is the world's leading crediting platform for engineering carbon removal. In addition to this, he is also author of the Corporate Metrics Technical Document and is a member of Singapore Institute of International Affairs. So for today's agenda, we have divided into 5 parts. The first one would be a brief green story introduction. Then we have Puro Earth journey, how carbon renewable technology is imported in sustainable fashion. Then we have Puro Earth technology and methodologies. Then we have Puro Earth case studies where we'll also see how different projects are ongoing and are in operation. And later we will have a Q&A session. So I'm introducing you Green Story, which has a vision to empower 1 billion people on their sustainable pathway. So we have a basic framework how we operate and how we make an impact through our clients and our customers. So first of all, we have to collect the data and understand the requirements of our clients. So when we have that, we go to collect data and measure the impact across their supply chains, their wholesale, retail stores, and the customers of the products which they are selling. So based on the calculated impact, we try to give them solutions, and on the basis of solutions and whatever the client is comfortable with, according to his or her needs and the budget part, we give them solutions and we try to reduce or offset the footprint across the chain. So this is how a normal framework across Green Story looks like. And talking about the framework, so that is enabled because we have an in-house SaaS platform. So in SaaS platform, we have each product mapped to it, and each product starts a journey from the raw material to the manufacturing stage to distribution to use phase, which is used by the customer, or also the end of life. So whatever is the phase, the impact is mapped and all the same is offsetted. So whenever an offset is done, we also provide them retirement certificates. And for the same, we also have a digital passport, which gives the summary of all the framework which we have talked about. Moving forward, Green Story serves clients across continents, and a few of the notable mentions are PAC, Pangaya, BAM, The Given Movement, Dock and Bay, Triaki, Cariloha, ThreadUp, and others. So we also have offices across Canada, Netherlands, and India. Moving forward, I will give my introduction here. My name is Gaurav Deshmukh, and I am product owner of Eco Contribution module at Green Story. So whenever we have a client and their impact calculated, we try to provide them solutions, and those solutions are not just related to carbon credits, but there are different opportunities to spread beyond the credits part. So we have different partners, and through which we have different options. To name a few: plastic credits with the help of plastic ban. Then we have ozone depleting substances through trademark. Then we have biodiversity units with the help of resets. And on the similar lines, now we introduce you to Puro Earth, which is a leading registry in terms of carbon renewable technologies. So, Mr. Lee, you may please take forward.
Thank you very much for the introduction, Mr. Gaurav. And good to meet everyone today. Good day. My name's Alvin. I'm calling in from Singapore, and I look forward to speaking with you for the next 20 minutes or so regarding some of the work that Puro.Earth is doing and how it links into the fashion sector, but also other sectors. So today I will be explaining the carbon standard, which is managed by Puro.Earth. That is called Puro Standard. Puro Standard is one of the independent carbon crediting standards in the voluntary carbon market. And we're the only one that's exclusively focused on carbon removals. So I will speak to you about how that works and some of the project types which are within our purview for certification. Next slide, please. So at Puro.Earth, to date so far, and we are nearing our 5-year anniversary, we have been very much focused on scaling the newest part of the carbon market, which are long durability, high quality carbon removals. So to date, we've had the honor of doing certifications for more than 70 projects. And by this point, they're spanning 17 countries, which effectively is every continent. So we're currently working in Asia, Australia, of course, EU, UK, and the Americas, but also Africa. And thus far, the combined removals that we've been able to certify has exceeded 500,000 tons. So while in aggregate, that's still a relatively small part of the overall challenge that we have globally for decarbonization. But it is noteworthy that in carbon removals, which of the engineered sort, that's a dramatic amount of work that has happened in the past few years. And our goal is, of course, to scale it to be billions of tons per year. So we'll talk more about why that is and how everyone can play their part to do that. Next slide, please. Just a bit about the structure of Puro.Earth. So Puro.Earth is currently majority owned by NASDAQ, but our minority shareholder is Fortum Energy, and we're headquartered in Helsinki, Finland. But as I mentioned, we're doing work in pretty much every continent. So we now have staff in each region to look for project developers who are running a successful carbon removal project. And we will undertake to have that project certified so that their work can contribute in a very meaningful way to the global voluntary carbon market. The name of our carbon standard is Puro Standard. And our company only has two services. So our principal focus is, of course, accreditation of carbon removal projects. And then finally, when a project is certified, they are issued carbon removal credits called CORCs. That stands for CO2 removal certificates. And that relates to our second service, which is we run what is called a registry. So the registry is the source of truth for which projects have successfully issued CORCs. And that is the only source of the CORCs, is that registry. And Puro's registry will be built on NASDAQ registry technology. I should also mention that at the moment, we have one independent endorsement, and that is from ICROA. So ICROA is an effort of the International Emissions Trading Association. So we have achieved that since last year, and that helps give confidence to potential users of these CORCs, and we'll talk about how that's used. But I should also mention that there are other independent endorsements that are important in the market. So we have publicly stated that we are currently seeking recognition from CORCs. So CORCs is related to the aviation sector, as a number of you may be aware. And we do see the important role of carbon removals to help the aviation sector reach net zero by mid-century. There's also a third endorsement program that is quite new that I'm sure many of you have heard about, which is the Integrity Initiative, or ICVCM. And ICVCM is famous for having published the core carbon principles, which increasingly are adopted and are driving the development of the carbon market. So more news to come in terms of Puro Standard having CORCs and or ICVCM recognition. But for the moment, we have ICROA, and that has served us well in unlocking a number of initiatives. Next slide, please. Okay. So thus far, I've talked about carbon removals. I also want to highlight some other terminology, just because you might hear it, and they're effectively talking about the same thing. So sometimes we hear about people saying, oh, there's a need for negative emissions technologies, or NET. So I'd like to highlight that because that is a useful designation. But whether you call it negative emissions technologies or carbon removals, in general, all these projects, what they're trying to do is scale up, because in order to meet net zero, we, as a global population, we will need to find a way to neutralize what we refer to as hard to abate emissions. So while it's of course important for everyone involved in any sector to be finding ways to lower their emissions, the general consensus and science have agreed that there will be certain levels of emissions that simply cannot be reduced further. So that's what we refer to as the hard to abate emissions. And that's why in order to get to net zero, you would need a negative emissions technology or a carbon removal, CDR, to neutralize that. Just to give you a sense of the numbers, it is estimated that of the 40 or 50 billion tons of emissions that we have today, if we all play our part, we could get that below 10 billion tons, perhaps even down to 5 billion tons. But it is hard to see how emissions would be lower than that. And thus, it is critical to develop a CDR sector that would be at least 5 billion tons a year. So that's the first point here. The units of Puro standard, which I mentioned, called CORCs, these qualify as durable removals. And so what we've seen is that what are the ways that the fashion industry or any sector can work with these? Well, firstly, if you've already forecasted what your hard to abate emissions will be, you can consider to procure and retire CORCs from the various project developers that we have certified, and those can play a role in neutralizing your company's residual emissions. So that's the most common way that companies are using this to address emissions. However, I will mention the second point here, which is this concept of warehousing. So we are starting to see some companies think about, well, what are my future neutralization needs? Not just this year's, but year by year. And so there's this concept of you can warehouse in advance CORCs based on your future estimated neutralization demands, or in some cases, companies are also entering into multi-year commitments to get a steady supply of CDR to meet their needs. So that's in general what we see happening. I would observe that some of the pioneering firms that are active in this way have been fashion, branded goods, but also to some extent aviation, selected transport sector. Financial services firms have also been playing a leading role in supporting CDR, and of course, technology and professional services. So these are some of the early movers where perhaps they're paying a somewhat high price for CDR, but that's what's going to build this industry, get more project developers to come into the space and bring the pricing down. And when the pricing comes down, then more participants from those sectors can be active, but it would also create opportunities for new sectors to participate, such as industrials, materials, and energy sector companies. Next slide, please. Just to get slightly more detailed about what exactly is a CO2 removal certificate and what is required for one to be created and issued to a project developer. So when we talk about carbon removal, actually there are three parts to carbon removal. So the first part is actually capturing CO2 from the atmosphere. Second part is what we call stabilization or transport, and the third part is storage. So in a sense, actually capturing may sound difficult, but actually there are some relatively easy ways to capture, but of course there are also some more exotic ways. And we are seeing a proliferation of different technologies come out that are involved with capture. Of course, we should not neglect the role of nature. So nature obviously is a natural capture mechanism. So when you have increased tree growth, for example, or mangrove growth, that is a natural capture. But likewise, we can use that same mechanism for engineered carbon removal as well. So for example, in normal forestry operations as well as agriculture, obviously CO2 is being captured by the plant and sequestered into the living organism. When we operate forestry and or agriculture activities in a sanctioned way or legal way and a sustainable way, invariably there will be some residues from the agriculture or forestry activity. Those residues, whether it's crop waste or forestry related waste such as sawdust, things like that, that is carbon-rich material. And so in the engineered carbon removal world, what we want to do is make use of that material. So in the capture part, you can also consider the fact that we can work with agricultural waste and forestry waste. So instead of burning it, as often happens, you find ways to transform that captured CO2 into something more permanent. And that's what we allude to here in the second step, this idea about stabilizing and or transporting CO2. So just using, again, the agricultural example to illustrate. So for example, let's take rice. So when we cultivate rice, actually the edible part of the rice might only be 70 some odd percent of the plant. Uh, Over 20% of the plant is not edible, but it contains CO2, or it contains carbon rather. And so there are ways to take the carbon in the agricultural waste and stabilize it. So one example of that is creation of biochar. So when you take organic matter and you change its molecular structure through either pyrolysis or gasification process, you get something much more stable. So biochar is a very stable form of carbon. So that's what that second step is alluding to. And then finally, you want to store that carbon. So what does that mean to store carbon or storing biochar in this example? Well, generally speaking, it means putting it to soil. Because once it goes in the soil, the carbon is locked there for a long time. Because biochar, because of its molecular structure, is very stable. And so those three steps combined are what gets you a carbon removal. And there would be similar kinds of steps involved for more some of the more exotic techniques. So just to walk you through one more, let's take the example of direct air capture. So some of you may have encountered some of those projects. So direct air capture literally requires industrial machinery to draw CO2 out of the air and separate it out of ambient air. Once you have that, well, typically there would be you would need to liquefy and or transport that CO2. And then finally, you need to store it. So typically, some of the things that we've seen are the injection of that captured CO2 into deep underground geological structures. There are ways to mineralize the CO2 and store it that way, or even store it above ground in the form of some kind of a solid that is inert. So that would be an example of capture, stabilization, and storage in a so-called high-tech way. So when you have these three elements and the project is audited, that's what enables the issuance of a CO2 removal certificate or a CORC. Next slide, please. Now, Puro's job as a standard is to define methodologies which are scientifically sound and vetted by independent advisory board, and we publish those methodologies. When a project developer is operating one of these projects, whether it's a biochar production or a direct air capture facility, actually it is not Puro who audits it. In the way the carbon market works, it has to be an independent auditor that will go to the site and check, are they doing all the things stipulated in the Puro methodology? And so that is the case for our projects as well. And so there are a slate of auditors that we work with. Sometimes these are referred to as VVBs, validation verification bodies. And whenever somebody buys a CORC, they can be assured that there was an independent auditor that was involved in checking that facility and confirming that the amount of carbon that was captured is indeed verifiable. Next slide, please. Just to give you briefly some history about how this all came about. So while the carbon markets have been around for decades, carbon removal is quite new. So it was actually April 2019 when the energy company in Finland, Fortum, incubated the idea to focus on doing work to scale carbon removals. There were some early support from some of the Scandinavian banks like SEB, but also the Swiss insurance sector. And then very importantly, I believe the world's largest carbon removal buyer, Microsoft, they made some initial commitments to support some of these projects. And from there, that's what has enabled this activity to scale. After that, NASDAQ took a majority stake into Puro. We started expanding our methodologies, and we formalized that by creating the registry, which I referred to in early 2022. So that's a bit about the history. Next slide, please. Here, I'd like to give a shout out to some of the early buyers of carbon removals. Now, carbon removals, or CDR, as you may have surmised, are substantially more expensive to produce than credit types such as emission reduction credits. And so we've been very privileged to be able to work with some of the leading companies listed here who understood the need to scale up carbon removals and supported it in the early days. I think I'd like to first highlight Frontier. So Frontier is actually a buying group. And importantly, I think especially for this webinar, Frontier includes as some of its constituents companies like H&M, but also has some other members, including some e-commerce firms like Shopify and a number of others. So they've been an important supporter in creating a fund exceeding $1 billion dedicated to supporting and helping to scale the carbon removal sector. I will highlight one transaction here since it's noted, which is that Frontier has so far made 3 rounds of allocations to carbon removals. In the third round, which was I think fourth quarter of last year or late third quarter, they supported a company called Puro.Earth. So Puro.Earth is doing enhanced rock weathering in India, and we'll talk more about what that is later, and that will be done in accordance with Puro standard. But likewise, the other 6 companies here have also played very important roles in supporting various parts of the carbon removal market. Next slide, please. I would now like to talk a little bit more about the specific kinds of projects that we look for. So we refer to these as methodologies. And then what we tend to see is that for each methodology, there would be a number of project developers globally that have the expertise to run those kind of projects and then would embark upon the process of setting up their facility, making sure it aligns with Puro's methodology, and then preparing themselves to be audited by the independent VVB. So just briefly mentioning the 5 methodologies so far, which have been approved by our independent advisory board. So the first one is biochar. So as we explained in some detail earlier, biochar is the process by which you take agricultural or forestry waste, you convert it into a stable form of carbon, and then you store it somewhere, typically in soil. We refer to this as a 100 years plus durable type of carbon removal. You will see some news and some debate out there about whether or not biochar can last longer than hundreds of years, even perhaps approaching 1,000 years. There's some debate as to what are the ideal conditions for that to possibly happen. But as of this moment, to be conservative, we refer to that as 100 years plus carbon removal. The second methodology we have is called terrestrial storage of biomass. So in comparison to biochar, which requires machinery to convert carbon-rich materials into a stable form of carbon, terrestrial storage of biomass approaches the same idea differently. It's taking carbon-rich material, usually waste wood, but instead of altering the molecular structure, it's about storing it in a way where there has negligible risk of methane emissions. So that usually means vaulting the biomass and keeping it dry. So there are some locations which are suitable for this, typically very dry and/or areas where there's a lot of land, but the land is not fit for purpose for other uses. For example, areas of land that are highly saline in the soil composition. So we're seeing some projects like that, which are leveraging those conditions to do terrestrial storage of biomass. And that's also what we refer to as a 100 years plus durable solution. The third methodology we have is called geologically stored carbon. And this is a general term that covers various techniques which fit into that classification. Now, you may more commonly hear about specific examples of geologically stored carbon. So I list out 3 of those here. So the first example is DACCS, which stands for direct air carbon capture and storage. So those are facilities that are literally running machinery, separating the CO2 out of the air and then storing it. A second example of geostorage is what we call BECCS, or BECCS, which is bioenergy with carbon capture and storage. So this is approaching the same problem, but differently. So for example, you can have a power plant, but perhaps it's running on wood chips, right? So some kind of a biomass powered power plant. Now, normally when you do that, after the energy is obtained, there will be CO2 escaping from the wood chips or the other material and back into the atmosphere. And you can, at least at a high level, think about that as a circular process. But what a BECCS facility does is it short circuits that by, instead of letting the CO2 come out of the biomass, you capture the CO2. And then again, same idea. You would liquefy, transport, and store that CO2. And then that would give you what's called a BECCS project. And then finally, a third thing that you may start to hear more about is very generally called biomass carbon removal and storage, or BICRS. So that covers a variety of other situations. I will just mention one, which is you can make biofuel from biomass, right? So things like ethanol. When you do that, again, you would be also releasing CO2 out of that process. And so if you're able to capture that CO2, liquefy, transport, and store it, you would have a geostorage project. So these are very exciting projects, and these are 1,000-year plus durability. Fourth methodology is what we refer to as carbonated materials. So in the case of carbonated materials, you are basically trying to create a physical solid or a material where the production process of that material actually absorbs CO2 from the atmosphere, either directly or indirectly. So unlike, for example, normal concrete production where you need cement, the production of cement is a highly emitting process. Carbonated materials is the exact opposite. So how do you do that? Typically, what's required are certain kinds of waste materials which are rich in particular kinds of minerals. For example, calcium and magnesium oxides and hydroxides. You will find such materials from a few places, such as steel production waste, or even waste to energy facilities. Some of the ashes would be rich in those minerals. If you mine those minerals and you are able to harness them to capture CO2 from the air, you will get a solid, and that is what creates the ability to create at scale physical materials which actually absorb more carbon than were emitted in the production process. So those are also 1,000-year plus durability. Finally, the fifth one, which I mentioned earlier, which Frontier supported from Puro.Earth in India, is something called enhanced rock weathering. Enhanced rock weathering leverages the same principles as the prior methodology in the sense that it is known that if you identify certain kinds of rocks that are rich in calcium and magnesium, if you manipulate those rocks by crushing it and dramatically increasing the surface area, you will find that there are ways to deploy that onto land in a safe manner, which then those materials would gradually absorb CO2 from the air into the minerals to form carbonates. And so that's a very important relatively new methodology called ERW. So these are the 5 methods so far that we have independently vetted, and we see that are scalable. But of course, our team is always on the lookout for new methodologies. So on the horizon are some blue carbon techniques, but there are others as well, and we hope to be able to introduce those to you in due course. So that's a bit of a technical thing. So now I want to talk more practical. So who's actually doing some of these things? So again, there's over 70 projects that have done work in these 5 areas, but I just want to highlight some of the recent ones, especially some that were maybe newsworthy and some that are close to this region. So I'd like to highlight just these 4 examples. So the most recent example is a company called Red Trail Energy. So this is an example of BICRS. Specifically, this company for quite a while now has been producing ethanol. So it's a biofuel. The feedstock is corn. And in the fermentation process, CO2 is released. This company has successfully captured the CO2. So there's a CCS on top of the ethanol production. And they are able to transport the CO2 and inject it into qualifying geological features in the United States, which are called Class 6 wells. And a very exciting project because because of the scale of their operations, they're successfully capturing more than 100,000 tons of CO2 through geostorage per year. And so they finished their audit just this quarter, several weeks ago. Second project I'd like to highlight because of its geographic location is Alcom. So Alcom is doing biochar production in the Philippines. They are using rice husk. So they're collaborating with rice mills and the rice husk waste, which previously would just be burned for some energy. Alcom is now working with rice mills to instead convert the rice husk waste into biochar. Now, interestingly, when you do that, you still release some heat. So there's still some useful heat that is made available, and which can have some electricity generation potential as well. So that still exists. But importantly, now the process also has biochar, and the biochar is trapping carbon that was in the rice husk, and it can be deployed to soil in the neighboring areas, which has benefits for the soil. So they had an expansion audit earlier this quarter, and this will help them further expand their facilities to other rice mills as well as other types of operations. Third one I want to highlight is Climeworks. So Climeworks arguably is one of the most famous projects because you see the picture in a lot of newspapers. What are they doing? They're doing direct air capture and storage, and they're doing that in Iceland as a start. So their first independent audit of their facility is happening this month with Puro Standard. And this project, because of its high profile, has successfully already obtained offtakes from the financial sector as well as the professional services sector and others. So some big names there. And the exciting thing about Climeworks is that their project type can be replicated to other places. So although they are building a larger facility now in Iceland, there are other geographies that they've identified where this work could happen. And then final example that's quite recent is I wanted to highlight is a entity called Varaha AG. So Varaha is largely based in India, but they also have a presence in Europe. And notable for them is that they've recently raised a quite significant amount of capital to support a number of projects, including carbon removal. And they're actively in the process of preparing for audit of a biochar production facility within the next month or so. So these are examples of fairly recent examples about how different project developers, or as we refer to them, CORC suppliers, how they are applying the 5 methodologies that I mentioned on the prior slide. Next slide, please. Now I want to talk a little bit more on the buyer side. So there are some recent case studies. So just going more or less in chronological order. So of late, Microsoft has been quite active. So last month, Microsoft did a very important deal whereby they are supporting a biochar manufacturer in Kenya. That entity is called Biological, and they're using agricultural residues, and Microsoft has allocated 10,000 CORCs offtake to Biological. Prior to that, just a few months ago, Microsoft also did something else very important, which is that they did an offtake for CORCs from an entity in Norway called Inherit Carbon Solutions. Now, this one's notable because of its novel approach. In the case of Inherit Solutions, they are going to different facilities where the facilities are generating renewable natural gas. And you can obtain that by putting organic materials into a digester or some other facility, and that will release useful natural gas. But again, the important thing is that there will also be CO2 as a side stream, and Inherit is successfully capturing the CO2, and they will be working to inject that into various storage sites in that part of the world. So Microsoft is supporting that project. A third transaction I want to highlight is Carbon Future. So Carbon Future has been helping a Bolivian biochar manufacturer called Exomad to get visibility for their CORCs. That was late last year. And then finally, I want to give a little bit more detail on the transaction I mentioned earlier, which is Frontier Climate. So again, Frontier Climate is a consortium of buyers, which includes H&M. And back in September, they made a $7 million allocation to CDR. And within that allocation was a very special project, which is Puro.Earth. So Mati, which physically operates in India, but they also have some scientific ties to the US. They are applying silicate rock powders to agricultural fields. They're starting with rice paddy in India, and that will enable them, we estimate in the next few months, to be able to undergo audit process for their enhanced rock weathering. So these are very exciting recent case studies. And then I want to highlight again the final point there, which is Puro Standard has submitted an application to CORCs because we do anticipate that there will be more needs for the aviation sector in the future for carbon removals. So we are preparing for that by seeking endorsement from CORCs. So that concludes the substantive part of what I wanted to cover in terms of methodologies, case studies of what buyers are doing, as well as the projects themselves. But I will just conclude here with one final comment, which is that If your company, if you're involved in the fashion sector or even others, if you're looking for access to CORCs for your net zero goals, how do you go about that? Well, in general, what we are seeing is that GHG advisors, firms that have the ability to measure carbon footprints and the marketplaces that they're connected to, these are good avenues to give access to the project types that I mentioned earlier. And Puro's registry is designed to support this. So Puro's registry is designed to enable a marketplace or a GHG advisor to pull CORCs from Puro's registry to their platform and then make that available to their customers. And so with that, I'd like to conclude the prepared parts of my remarks, and thank you very much for joining, and happy to talk to you further about negative emissions and CDR. There are some appendix slides here, which I'll leave in case people have questions, but I don't think we need to go through these in detail unless people want to.
Yes, so this is also one of the project of Puro.Earth, which is biochar. So he has also explained it. Then we have terrestrial storage of biomass. The same, it is for permanence for more than 100 years. Then we have geological store carbon. I think Mr. Alvin has briefly talked about this, which includes direct air capture also. Then we have carbonated materials, obviously, I would say alternative of cement, but yeah, better alternative. Then we have enhanced rock weathering, which is also upcoming project, I would say. So this was all about the different projects which the Puro.Earth has, and right now we are into Q&A session. So anyone has any questions can directly ask us or can write in the chat itself, and we are happy to answer it.
So I think we have a question in chat, which is basically CR projects are very expensive right now for a lot of brands. Do you foresee costs coming down over time? That's a question for you. Yeah.
Sure. Thank you for the question. So firstly, perhaps we can talk about the overall challenge that most companies face. So at the moment, most sectors seem to be aligning towards a net zero future, right? So whatever is the current level of emissions that you have, there will of course be efforts underway to lower those emissions. So in general, we would always observe that the most economical approach would be to find ways to reduce the emissions in your existing process, however possible. Because typically those will be the most cost effective for you to do. But as I mentioned earlier, there are in general some very hard to abate residual emissions for most sectors. And so that's where CDR comes in. Now, it is also true at the moment, depending on the country, as well as the claiming standards, there may still be the ability to utilize emission reduction credits to address some of your residual emissions. And, of course, you should work with your advisors and check by jurisdiction how that works. But I think it's quite irrefutable that using a carbon removal would definitively help to neutralize those residuals. So at the moment, out of those 5 techniques that I mentioned, yes, in general, they are in excess of $100 a ton to operate. We would observe that if you look at most of the academic studies about the social cost of carbon, the social cost of carbon is said to be quite a bit in excess of $100 a ton. And so we would say that carbon removal prices are somewhat aligned with the true social cost of carbon. But nevertheless, as a company where you're operating with tight budgets and you're accountable to your shareholders, you are, of course, probably looking for ways to not only do the right thing, but also hopefully see that these solutions are coming down in cost over time. So to most directly answer your question, yes, we do see that as these solutions scale across all 5 of those methodologies, they will all get more, they will all become less expensive to deliver over time. It could take a while though. To some extent, they may compete with each other, and there will be new methods coming. And so that's what we would expect in any open market kind of process. But that being said, it is quite expensive to remove CO2 from the atmosphere, whether directly or indirectly. So we do see some technologies that are going to change that, but it's going to be expensive. So that's why you need to combine your decarbonization efforts together with factoring in how you would use carbon removals.
And the related question is, how do you price the CORCs?
Yep. So the prices which I cited, those are controlled by the project developers. So the only thing that Puro does is we certify that a project developer or a supplier, we certify that they are properly following one of the 5 methodologies, and then we measure how much volume of activity that they're doing. Once we do that, they are issued CORCs into the registry. Once the project developer has the CORCs, you can view it as an asset or a commodity that they control. So it's entirely up to the project developer to set the price at which they want to sell. So it is not set by Puro.
Just one
Understood.
thing for the pricing part we are discussing. So as a company, like if I want to go for COGS, so what would be the best approach at the supplier side or at the buyer side?
I see. Yeah, thanks for the question. So if I understand what you're asking, you're right. Although I mentioned a number of examples where the companies are just directly purchasing the CORCs, so that's Microsoft, that's H&M through the Frontier Group and others. It is also true that some companies, in addition to them trying to cut emissions wherever they can, some companies are contemplating actually developing a project, and they might follow one of the 5 methodologies I mentioned, such as, let's say, biochar. And so some companies are exploring basically taking that in-house. Now, is that going to be a better outcome for them or not? Well, it remains to be seen, right? Because it's not easy to run the machinery, go through the certification process and all that. But yes, some companies may have that capability or may have partners that can help them. So we're seeing some companies contemplate that, but it is not a small endeavor, I would say.
Rightly said. And also, like when we are talking about costs, so as per GHG protocol, what all scopes did it adhere to?
So, so I must make the disclaimer that I'm not an expert on GHG protocol. It comes up a lot, but of course, it's GHG protocols control over how you follow the rules and what claims you can make. The only thing that I can say is that in the case of CORCs, so CORCs are by design certified to be long duration, or quote unquote permanent carbon removals. So a user of a CORC can be highly confident that it is removing CO2 from the atmosphere and stored away for a long, long time. And so then the question becomes, if you're following GHG protocol, so you'd have to check, well, does GHG protocol, based on my limited understanding, GHG protocol, you have to report, of course, your emissions. But would GHG protocol allow you to directly neutralize one of the scopes if you purchase CDRs, or does it ask you to report that separately? I'm not sure. Probably you know better. So I know that, for example, with something similar, which is SBTI in general, the idea seems to be that, well, of course you should be decarbonizing, but you're also encouraged to support beyond value chain mitigations. And so my general sense is that SBTI is moving towards a dual track reporting. So you report your own progress, but you can also separately report how you're supporting BVCM. For GHG protocol, perhaps it's something like that, but I'd actually defer back to you on that, Gaurav.
Yeah, so in that case, like as you have said, direct air capture. So I would say that would come under scope one, if that project is direct air capture. And if there are rest of the technologies, then obviously if we report them, then we can include in scope two.
Yep, very good.
Yeah.
So there's one more question from the group. How scalable is ERW? What are the issues with ERW apart from measurability? And how is MRV being addressed?
So I would make the following observations. In general, when Puro adds a methodology, not only does the methodology have to be scientifically defensible, typically we would also look for methodologies which are highly scalable. And so the general consensus is that for biochar, if all things being equal, there could be hundreds of millions of tons of sequestration if done properly and extensively through biochar, perhaps even more. Direct air capture, I think, has a very broad consensus that it is a billion-ton plus kind of solution if deployed at scale. ERW, in general, because of the prevalence of the mineral-rich rocks, has the potential to be possibly a gigaton scale. So that's the first part of the question. So in other words, it would be a highly meaningful contributor towards the future goal of trying to neutralize 5 billion tons of hard-to-abate emissions. So ERW could play a very large role there. In terms of how to do it and the measurability or the MRV, well, that's work that's actively taking place right now. So for those who are familiar with ERW, you might have looked at some of the methodologies, and you will see that ERW depends on the ability of the project developer to specify what it is that their location could be doing. In other words, if you deploy the minerals in a certain way, how do those minerals then permeate the soil and interact with water and then transport away carbonates? And so there is a requirement to specify what is the mechanism that you see happening at that site. Or said differently, you need a mathematical model to try to describe what's happening at the site. However, once you have that, you then need to measure the soil and or water to get the data that goes into that model. So there is a definite MRV component in the sense that you have to take measurements from the soil and water in that area. But governing the use of that data is a notion of there should be a model that you assume is working. And so there are various models that are understood and kind of agreed upon by geologists for those. It's not only one, there are a few. And we are seeing the different proponents of models come together into forums to try to unify on what are some accepted small number of those models, and what are the best practices in frequency and density of taking those soil samples and water samples so that the results are reliable. So there's a lot of work happening there. It's happening in many countries, and I'm quite encouraged, I would say, at the degree of cooperation across countries and projects to try to make this a highly transparent and accepted approach to carbon removal.
All right, that's all the questions mentioned here.
Thank you so much. And moving forward, so if you
Thank you.
have any details or doubts or any queries, do let us know. So we'll have our contact details here, and you can contact us directly. And thank you so much, everyone, and thanks for joining. And have a good day.
Thank you.
Thank you.
Yeah, thank you.